Okay, 69. We have the real roots -1/2 and 0 and 1/2. And we also have 2 f of -2, f of -2 is equal to -2, and what's f of -2? It's 6. Okay. They don't mention multiplicities, so we assume they're all multiplicity 1. Okay, so that means f of x will equal some constant. It's a non-zero constant. If it was 0, then f of x would equal 0. Okay, so we don't want quite to do that. Alright, now for the first factor we could use this as one of the roots here, 0. You could write x minus 0 in parentheses, because if x equals 0, 0 minus 0 is 0. But instead we'll just write x, because x minus 0 does equal x. Right? So if x equals 0, then that's going to wipe everything else out. Okay? So there's no need to write x minus 0 there. And then we've got x plus 1/2 from that one. So if x equals -1/2, -1/2 plus 1/2 is 0. And then we've got x plus 1/2, or rather x minus 1/2 from this one. All right, x minus 1/2. So if x equals positive 1/2, 1/2 minus 1/2 is 0. This would be 1/2 plus 1/2, and that would be 1/2. But 0 times all of that is going to make everything vanish. Okay, and that'll be a 0. Okay, and so you could multiply this through and then multiply the result by that if you want, or you could multiply these two first. This might be easier. X plus a, x minus a is x squared minus a squared, right? And then you can multiply the x through. Well, it's your choice how you want to do that. You can leave the a in front for simplicity's sake, especially when we solve for a. So we should get x cubed minus 1/4 x. Okay. Now use the fact that f of -2 equals 6. All right. So that means f of x, set f of x equal to 6, but let x equal -2. Right here and right there. Okay, so you got -2 cubed minus 1/4 times -2, and set that equal to 6. And so you multiply all that out and you do the math there, and you get -15 halves, -15 over 2a. And then solve for a. So you get a is equal to -12/15, which reduces to -4/5. Therefore, f of x is equal to, what's a? It's -4/5. X cubed minus 1/4 x. Okay. Now the book's answer is a slightly different. It's -1/5 times the quantity 4x cubed minus x. But what they did was they took the 4 and multiplied it through, and they left the -1/5 out in front. So they're equivalent answers. So you take that 4, consider it a positive 4, multiply it through. I know there's a negative in front, you leave that in front. Alright, so you just write, take the 4 and you multiply that through. And so you get 4x cubed and then minus 4 times a fourth is 1, so that's just x. So why do it that way? Well, you could consider that as a little more simplified because there are no fractions in here. Okay, here there's a fraction. So if you were to put this answer on test, for example, I'm sure your professor would give you full credit for that. All right, if the professor knew what he or she was doing, he or she would know that these two answers are equivalent. All right, and if he or she doesn't know that, then I submit to you, you need to find a new professor. Okay, but yeah, they are equivalent, and you should know that yourself when you check your answers in the book. If your answer is slightly different, check and see that they're equivalent or not. Okay, then maybe you can go back and look for mistakes that you might have made. And if you can't find any, maybe the book made a mistake. Okay, but chances are the error is yours, right? Because you have less experience than the book people do, right? That's the assumption. But check and see if they're equivalent, because you may have gotten the right answer and not know it. All right, so you have to do a little bit of investigation there. Okay. Okay, here we go with 71. For the following exercises, find the dimensions of the box described. So, the length is twice as long as the width. The height is 2 inches greater than the width. The volume is 192 cubic inches. Alright, so let's start with the length. The length, call it L, lowercase l, is twice as long as the width. We'll call it width W. That sort of makes sense. And the height, let's call that H, equals 2 inches greater than the width. So 2 plus W, or W plus 2. 2 inches greater than the width. The volume, well, what is the formula for volume of this box? It's length times width times height. And it happens to be 192. So the problem that we have is we need just one variable to solve for, and we've got 3 here. All right, so we will use these equations to get just one variable. All right, so the volume is 192. That equals length, which is 2W, times width, W. Apparently we're going to use W's for our variable to solve for. Once we know what W is, we can use these formulas or these equations again to solve for the other 2 variables. All right, so, and height is W plus 2. So there's length times width times height. Okay, and you multiply everything together. 2W times W is 2W squared, and then multiply the 2W squared times that. So you end up with 2W cubed plus 4W squared. All right. Now, what we can do is you can subtract 192 from both sides of this equation, set it equal to 0. All right. So I'm just going to write the right-hand side of the equation in front here. It really doesn't matter. You could write this first and set it equal to 192, you know, going this way. Let's see, 2W cubed plus 4W squared minus 192 equals 0. Now there's a common factor of 2. here and here. Is that a factor of that as well? Yeah. So we can simplify a little bit. Divide everything on both sides by 2. So what you get is w cubed plus 2w squared minus 96. And of course 0 divided by 2 is 0 still. Alright. So it doesn't say how to solve this, or it doesn't specify how we should solve this. I suppose you could use your grapher, your computer algebra system. Alright, if you want to do this the hard way, and in keeping in the spirit of this section, you could do it by hand using the techniques we've already learned. Alright, so you write the possibilities for P over Q. Alright, the possibilities for P over, well actually all you need is the possibilities for this, the factors of this, because the leading coefficient is 1. So I'm just going to rattle them off to you. I'm not going to write them down. Plus, they're all plus minuses, so keep that in mind. 1, 2, 3, 4, 6, 8, 96, 48, 32, 24, 16, 12. I know that's out of order, but anyway, there they are. Okay. So it turns out that 4 will work. Let me do that up here. Let me see, I'll just divide it off with a line. 4 works on this polynomial. Let's see, we've got 1, 2, 0, negative 96. So we've got 1, 4, 6, and 24, and 96. Alright, so this polynomial will equal w minus 4 from that 4 times w squared plus 6w plus 24. Alright. Now, there are, for this quadratic, if you look at the discriminant, that's b squared minus 4ac. Alright? That would be, in other words, 6 squared minus 4 times 1 times 24. That's a negative number. Alright? So you're going to have a negative number under the square root in the quadratic formula, which means you have a non-real situation there. So there are no real roots to this quadratic. So the only thing you have to work with is this, and that's very nice because w must equal 4, right? So w equals 4, and then you can solve for these two variables. Alright, so we've got L equals 8 and H equals 6. Okay, 73. The length is 1 inch more than the width, which is 1 inch more than the height. The volume is 86.625 cubic inches. Alright. So the length is 1 inch more than the width. Length equals w plus 1. And the width, well, let's see. The length is 1 inch more than the width, which is 1 inch more than the height. Okay? In other words, they're talking about the width. The length is 1 inch more than the width, which refers to width here. The width is 1 inch more than the height. Okay, so W equals h plus 1. Alright. So what we want are, well, how about all w's? So solve this for h. H is w minus 1. So we have length in terms of w, we have height in terms of w, and w is, of course, in terms of w. Alright, so what do we have here? We have length, width, height. Okay, so that's w plus 1. Length times width times height is volume. And w minus 1. And w is 86.625. Oops. Don't write that 2 just yet. Jumping the gun, as they say. 86.625. Okay. Back when they used to use guns to start a race, with blanks, of course. They don't do that anymore. Okay, so we've got a plus b, a minus b is a squared minus b squared, or w squared minus 1 times w equals 86.625. And then multiply everything through, you got w cubed minus w, and then subtract that from both sides, minus 86.625 equals 0. Alright, now since this is in decimal form, it's a natural candidate for solving with a computer. But, well, I wonder, can we do this by hand? Sure. You might be interested to see how you would do this by hand. Alright, first you've got to get some rational numbers going here. 86.625, what is that? 86.625 is 86 and 625 1/1000ths. That's the 0.625 part. And that can be reduced, the fraction part, to 86 and 5/8. And then you change that to an improper fraction. That's 693/8. Just go 8 times this and then add 5 to the result. All right. Now let's so what we got is this at the end right here, 693/8. All right. So we have to come up with all, the leading coefficient is 1, so we need all the factors of 693/8. Well, how do we split up 693? You can do that up here. Divide 3 into 693. Because it looks like 3 will go in there, which it does. And you get 231. I'm writing it this way because it's a little easier to factor these divisions. 3 will go into 231 77 times. 11 goes into 77 7 times. So 693 is 3 times 3 times 11 times 7. Okay. So the possibilities that we have would be all pluses and minuses. You could write 1, of course, 693/8. You could write 3 over 1, 3 over 2, 3 over 4, 3 over 8. All right. So when you've got the factors of 693 over the factors of 8, in other words. So I've got 3 over 1, 3 over 2. See, these are all factors of 8. 1, 2, 4, and 8. 3 over 4, 3 over 8. And then we can go to 3 times 3 is 9, so you got 9 over 1, 9 over 2, 9 over 4, 9 over 8. You can have 11, and so on and so forth, right? you just get combinations of these numbers for the 693. And well, that's a lot. That's a whole lot, okay? That's a lot. But I'm going to show you what'll work. I mean, what I'm showing you is you can do it by hand if you've got a mind to, or if you're forced to do that. You can do this one by hand. It's possible. All right. So don't think that, oh my gosh, you know, what am I going to do without a computer? Well, yeah, you've got a human mind. You know, it just takes a little work, a little more work, right, than maybe we're used to nowadays. But just think, back in the old days, they had to do this all by hand. Oh my gosh. So don't feel so bad. 9 over 2 works. All right, we've got 1, 0, negative 1, and then negative 693/8. So this is 81/4. 81/4 minus 4/4, in other words, is 77/4. And then we've got 693/8, positive. Okay, so this polynomial up here equals w minus 9 over 2. Okay. And w squared, coming from this, plus 9 over 2w plus 77/4. All right. Now the discriminant on this, b squared minus 4 times a times c, turns out to be a negative number. It's easy to punch that into a calculator and get that result. It really doesn't matter what the number is. If you know it's negative, you know you've got no real solutions, okay? So you don't even have to bother with this. Just this. Set that equal to 0, solve for w. That's easy. 9 over 2. You don't even need a calculator. Do that in your head. So w over 2, or rather w equals 9 over 2. Change that back to decimal form. That's 4.5. And then you can solve for the other variables. L is 5.5 and h is 3.5. All right, there you go. Number 75. The length is 3 inches more than the width. The width is 2 inches more than the height. The volume is 120 cubic inches. Okay, so the length is 3 inches more than the width, or width w plus 3. The width is 2 inches more than the height. W width is 2 inches more than the height, or height h plus 2. So since L is in terms of w, we can write h also from this equation in terms of w as well. Just subtract 2 from both sides and you'll have h equals w minus 2. Therefore, h equals w minus 2. So now we can write volume would be length times width times height, and they will all be in terms of w. So length is w plus 3. Width is h is w minus 2. So length times width, that's w minus 2. And then width is just width, w. Alright, so that equals the volume, which is 120. So if you multiply all this out and then subtract 120 from both sides, what you get is w cubed plus w squared minus 6w minus 120 equals 0. Okay, so there's our equation. And the leading coefficient is 1, so the possibilities for the rational roots would be factors of just 120. And 120 is 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, 10 times 12, or 1 times 120. So of all those possibilities, 5 works. So we've got 1, 1, negative 6, negative 120. Okay. So this equation, or this polynomial rather, on the left side of this equation is w minus 5. That comes from this. And then using this part, w squared plus 6w plus 24. Alright. Now, if you look at the discriminant of this quadratic, that will be less than 0. b squared minus 4ac, right? That's going to be less than 0. So there are no real roots to this quadratic right there. So the only real solution would be from this part, this factor, w minus 5. And that means if w set this whole thing equal to 0, then w equals 5. So w equals 5. And then from that you can calculate or compute what the other variables are. L equals 8 and h equals 3. (77) For the following exercises, find the dimensions of the right circular cylinder. Describe. So if you recall, the volume of a right circular cylinder is V equals pi r squared h, where V is volume, r is radius of the circular base of the cylinder, and h is the height of the cylinder. Alright, so it says the height is 1 less than 1/2 the radius, and the volume is 72 pi cubic inches. So the height is 1/2, or 1 less than 1/2 the radius. So you write 1/2 the radius, 1/2 r, or you could write that as r over 2, and it's 1 less than that. Alright, so that's 1 less than half the radius. And then we've got V equals pi r squared h. And so the volume is 72 pi. So set the volume to 72 pi. And then you've got pi r squared times h, which is 1/2 r minus 1, or you could write that as r over 2 minus 1. And there you go. So divide both sides by pi. That gets rid of that little thing there. Alright, so you got r squared times r over 2 minus 1, the quantity, is equal to 72. So you've got 1/2 r squared minus r, or 1/2 r cubed minus r. If you r squared, multiply that through. 1/2 r cubed minus r squared equals 72. And we can clear the fraction by multiplying both sides by 2. So 2 times 1/2 is 1, so that's r cubed minus 2r squared equals 144. And you can subtract 144 from both sides, set it equal to 0, like that. So the leading coefficient is 1, so all you have to do is find the factors of 144 to get all the possibilities for the rational roots. All right. So 144 is 12 times 12, 8 times 18, 6 times 24, 4 times 36, 3 times 48, 2 times 72, 1 times 144, and 6 will work here, 6. And you've got 1, -2, 0, that's for 0r from this polynomial, and -144. Like that. So that means this polynomial is equal to r minus 6, which comes from this. And then what we have left here is r squared plus 4r plus 24. All right. You set that equal to 0 and you solve for r. So the discriminant on this is less than 0. B squared minus 4ac is less than 0, so the discriminant less than 0 tells you that there are no real roots, okay, for this factor right here. So this is the only real root that we're going to get from this factor. That's r equals 6. So we have r equals 6. And then you can plug in r equals 6 right here and get the height. Alright, so the height is 2. $79. This is it, guys. The last problem in this set. Here we go. The radius and height differ by 2 meters. The height is greater, and the volume is 28.125 pi cubic meters. So the height is greater than the radius. You don't really need to write this part. But since height is greater than radius, you know that h minus r will be greater than 0. Alright? So h minus r, in other words, the difference of the height and radius is 2 meters. Alright? So the radius and height differ by 2 meters. So h minus r equals 2. Okay? So how do I know it's h first and then r? H minus r instead of r minus h. That could also be the difference between the radius and height, right? That could be the difference. So why not r minus h equals 2? Well, we've already established this fact, right? H is greater than radius. So if you subtract r from both sides, h minus r will be greater than 0. If you go the other way around, r minus h, It's going to be less than 0. It's going to be negative. Okay, so it can't possibly equal positive 2 in this case. Like r minus h cannot be positive 2. Okay, so that's how we know to put h first. And so we've got h minus r equals 2. So that means h equals r plus 2. All right. So v equals pi r squared h. And that's v is 28.125 pi equals pi r squared times the quantity r plus 2. That comes from the h here. So now everything's written in terms of r. So divide both sides by pi, you get r squared. What I'm doing is writing this side first. R squared, after dividing by pi on both sides, r squared r plus 2 equals 28.125. If you multiply all this through and then subtract this from both sides, you end up with an equation, r cubed plus 2r squared minus 28.125 is equal to 0. Okay, so what's 28.125? 28.125, what I'd like to do is try to factor this, if I'm going to do it by hand, that is, to get the possible rational zeros, right? So that's equal to 28 and 125 1/1000ths. And that's equal to 28 and 1/8. Which is 225 over 8. Okay. So you can find the possibilities for rational zeros by factoring this. So remember that, or you can see that 225 is equal to 225 times 1, 15 times 15, 9 times 25, 5 times 45, 3 times 75. And then you would write all the possible factors of this over all the possible factors of 8. And that's a long process, right? So it turns out that 5 over 2 works. 5 over 2, because 5 is one of the factors. 5 times 45 for 225. 2 is a factor of 8. So 5 over 2 does work. Let me just divide this part here with a line. And we've got 1, 2, 0, negative 225 eighths. So that comes from this right here. So let's see. So there we go. Okay. So this polynomial on the left-hand side is equal to r minus 5 over 2 which comes from that 5 over 2 there. And then you've got r squared, so r squared plus 9 over 2r plus 45 fourths. Okay. Now the discriminant for the quadratic factor there, I'll just write DISC for discriminant, is b squared minus 4ac, or 9/2 squared minus 4, a is 1, c is 45/4. You could do all that on a calculator. You don't have to worry about getting a fraction. I mean, you just want to find out if it's negative or 0 or positive, right? So if you do it by exact method, using your hand, or maybe calculators can do that nowadays, you get negative 99/4, all right? So just the fact that it's negative is all we need to know. There are no real solutions for this quadratic here, this factor. So the only solution, real solution you get is from this factor. And so r equals 5/2. Which is the same as 2.5. So r is 2.5, and then you can use this equation here to calculate what h is. That would be 4.5. Alright, well there you go. That takes care of this section. Another one bites the dust, and it's time for a pause for refreshment, right? So get yourself something to refresh you. Pat yourself on the back for a job well done, as usual. All right, good for you for hanging in there this far, and it's going to keep going, but we can take a little pause here. But we'll be back. Don't touch that dial. We will be back with more solutions for you in the problem section. So take care and have a good one. We'll see you later.